Okay, so we are on page 4 for today. We got it last week. If you can't find it, take notes on paper for today. We're on page 4 for today. And we're going to start doing stuff that we have already done. So last week we were looking at exponent rules, right? We did a review of what to do if I have exponent outside of parentheses or something to the 0 power, if we have negative exponents, if I have things with the same base that I'm multiplying, a power to a power. We did a review of all those things. So today we're going to practice using those ideas. Okay, so we've got 3 functions up at the top, all with some kind of exponent. In some case, or in each case, we have some sort of something with a variable, right, to a power. And what we're going to do is practice some stuff that we did last week, some evaluating work. So we have, in our first sort of little box here, set of boxes, we're going to find h of 3. So what is this telling me to do, h of 3? Mm-hmm. Mm-hmm. And then what am I going to do with that function? Perfect. So I find h of x and we plug in 3 for x. So this would be 3 to the negative second. And now I want to simplify each of these as much as I can. So what does that negative exponent tell me to do? Negative exponent. Take the reciprocal, right? So this would be 1 over 3 squared, which would be 1 over 9. We're always simplifying as much as we can. For g of negative 3, same idea. Okay, we're going to take our function g and plug in negative 3 for x. So this would be 2 times negative 3 to the second power. So we're going to multiply inside parentheses first. That would give us negative 6 to the second power. Do I need to take the reciprocal here? No, we take the reciprocal when the exponent is negative, not when the number is negative. And then negative 6 squared would be negative 6 times negative 6. That's 36. And then we've got a couple compositions here. Again, that's something we did in our last unit. We worked from the inside out. So this would be f of negative 1. So I find my function f of x. I plug in negative 1 anywhere I see an x, and we simplify. So this would be, careful when you're taking odd powers with negative numbers. We're so used to there's an exponent, so now it's not negative anymore because we do so much squaring. But remember with a cube, that's negative 1 times negative 1 times negative 1. So when I multiply 2 of them, I get 1. And then I multiply by another negative 1, I'm back to negative again. And then a mistake I saw on some, or an error I saw pretty frequently on some of our last quizzes that we had, okay, over Unit 1, when we had compositions, I had quite a few people where when we were working in compositions in that unit, we did a great job. But by the end of the unit, I had some people in a problem like this find f of negative 1, then find h of negative 1, even if that wasn't what you got here, and then multiply those 2 answers together. That is not what we're doing with a composition. For a composition, we work from the inside out. Once I have the output for f of negative 1, this is now my input for h. And then once I use this as an input, I am done with that value. I don't need to call back to this again. I'm using it as my input for h. So this would be negative 1 to the negative second power. We do need to take the reciprocal on this one since our exponent is negative. This would be 1 over negative 1 squared. That would be 1 over 1, which is just 1. And that's my final answer. I don't need to do anything else but the negative 1 from my f. And then g of 5. So again, work from the inside out. G of 5 means we are plugging in 5 to our function g of x. So that would be 2 times 5 squared. 2 times 5 is 10, so 10 squared. gives us 100. And now we use this as our input in our outside function, which for this one is also g. So g of 100 now. So that means I would do 2 times 100 squared. So that's 200 squared, which would be 40,000. In our next couple of examples, we're going to see some compositions again, but this time, because our functions all have exponents, we'll need to bring in our exponent rules to help us simplify. We've also got some multiplication of functions here. Okay, so we'll take f of x and multiply it by g of x. Again, since I've got exponents in all of my functions here, I'm going to bring in those exponent rules. So f of x times g of x, f of x is x cubed, and we're going to multiply that by g of x, which is 2x all squared. So for my exponent rules, I'm going to distribute in this power to start. So this would be x cubed times 2 squared times x squared. 2 squared is 4. And then we are multiplying terms that have the same base, right? X cubed and x squared. So we add their exponents, 4x to the 5th. I've got a little bit more complicated expression that I've put together for my second box here, but that's okay. We're just going to follow our exponent rules. So f of x is x cubed, and we are dividing that by g of x, which is 2x all squared, and then multiplying on the bottom by h of x, which is x to the negative 2nd. Now, last time we talked about how for a lot of our exponent rules problems, as we're simplifying, there's usually more than one correct first step. I also told you that I am someone who generally prefers to not have negative exponents. So my first step for my own personal preferences is usually to move the thing that has the negative exponent. So my first step in a problem like this is probably going to look like this. I'm going to just take my x squared and move it up to the top so that that exponent is not negative anymore. That doesn't have to be your first step, though. Your first step could be to distribute in this power. That would be fine. I'm actually going to do that now. So we would have x cubed times x squared over 4, right? 2 squared is 4, x squared. I could have also, as my next step, combined my x's here. That would give me x to the 5th. Okay, that would have been fine too. Or if you distributed first and then combined your x's on the bottom and then combine whatever you had left with the x on the top, that would have been okay as well. At this point, though, I can see I've got x squared on top and on bottom. We looked at a couple of problems similar to that last time. I think we had one that was like c to the 5th over c to the 5th. And we said I would subtract those exponents, and that would leave me with x to the 0, which is just 1. So I actually don't need either of those x squares anymore. And my final answer would be x cubed over 4. In my last section, we went over this problem in a little bit different way. We still got x cubed over 4. Okay? So there are multiple correct avenues through this problem. And then our last couple examples on page 4 are composition functions again. Okay? This time I don't have a value plugged in, so we're going to keep f of x as it is and plug it into g. So f of x, remember, is x cubed. So I'm going to plug that in for x in my function g of x. So this would be 2 times x cubed all squared. I'm going to distribute in my exponent. That would be 2 squared. And then where I already have a power, we multiply x to the 6th. One more step to clean this up, and we get 4x to the 6th. Our last composition, same idea. I've got g of x inside here. So if I look at the top, here's g of x. I'm going to plug this whole thing in for x in h of x. So this would be x to the negative second power for h of x. And then plugging in for x, I put g of x. So 2x all squared. Again, there's more than one correct first step here. I could start with this square on the inside and distribute it in, and then distribute in the outer power. That would be fine. I'm going to go ahead and just, since I've got power to a power, multiply those right now. I've given 2x all to the negative fourth power. And then what does that negative exponent tell me to do? Flip it, right? Take the reciprocal. So this would be 1 over 2x all to the fourth power. I could have also flipped this at the beginning. That would have been fine too. Just would have still had those double exponents. And then I'm going to distribute this power through. So this would be 1 over 2 to the fourth, x to the fourth. 2 to the fourth is 16. So this would be 1 over 16 x to the fourth. Same composition of functions that we did in our last unit, but now bringing in those exponent rules. And then our last problem here asks us to find the y-intercept. That's again something we did in our last unit. I don't want you to forget. That's not something that's going away. So how would I find the y-intercept if I know the function? What could I do? Plug in 0 for x. So f of 0 would be 0 cubed, which is just 0. G of 0 would be 2 times 0 squared. So 0 squared, which is 0. And then finally h of 0. So that would be 0 to the negative second power. Remember that negative exponent tells me to take the reciprocal, so this would be 1 over 0 squared. That's actually a problem, 1 over 0 squared. What's the problem with this? Well, it's not 0. The whole thing is not 0. When I divide by 0, anybody remember what we call that? Undefined, okay? So in our last unit, we talked about a couple of instances where we wouldn't have a y-intercept for a function. The two that we focused on were if I take the square root of a negative number or if I get something that's undefined. Since we have something undefined here, that means h of x has no y-intercept. Questions for me so far? Everything that we have done up to this point is not new. This is not a new thing that we've done today. We've done evaluating, we've done compositions, even for this sort of second set of problems where we had to use exponent rules. We reviewed exponent rules last time. This was not new. We've done y-intercepts before. This is all stuff that we have seen before, okay? So on the next page, I want to talk about something that is a little bit different than something we've done before, okay? One of the tools that we will use a little bit later on in Algebra 2 is, or one of the skills I should say that we'll work on is solving. And for some of our exponential functions, the easiest option that we have to solve is to be able to rewrite our problems so that whatever the exponent is, the base is the same, okay? So we'll be able to figure out when I've got a variable in the exponent, what that variable is equal to, what x is equal to, by getting the bases to be the same, the bases of those exponents. So we know if I've got x squared times x cubed, it's okay to be able to combine those terms, okay, because the bases are the same. But if I had something like x squared times y cubed, I can't do any combining there. The bases are different, so I'm stuck. This is true with numbers also. Okay? And so one of the tools that we want to be able to have in our tool belt is if I've got bases that are the same, even if they're numbers, that means that I can use the same exponent rules. But if I have bases that are not the same, I can't rewrite them, right? I have to have bases that are the same in order to use those exponent rules. Now, over here, since I've got numbers here, 2 and 4, we can actually both write as powers of 2. 2 is already written with a base of 2, but 4 I could write as 2 to some power. So 4 would be 2 to the what power? Yeah, 2 squared, right? So instead of having 4 here, we can write this as 2 squared. And then still with this original cube there. Once the bases are the same, then I can use my exponent rules. Okay? So that's an idea I want to practice here. So I want to rewrite each of these as a power of 2. So 4 is 2 to the something. 8 is 2 to the something. And 16 is 2 to the something power. 4 is 2 to what power? The second, right? It's 2 squared. So instead of saying I have 4 here, we can say I have 2 squared to the second power. Right? Original exponent stays, we're just replacing it with 2 squared. Kind of similar to that composition idea that we worked with. And then 8 would be 2 to the what power? 2 to the third. So here I can say I have 2 to the third power to the 1/3 power. And then 16 is 2 to what power? 2 to the fourth. So this is 2 to the fourth, the x plus 1. And then in some of these cases, we can simplify. So this would be power to a power we multiply, 2 to the fourth power. Power to a power we multiply, this would be 2 to the 3/3 power, or just 2 to the first. And then here where I've got an expression for my exponent, I'm still going to multiply, but we have to distribute. So this would be 2 to the 4x plus 4 as my exponent. So if I needed to, let's say I had 4 squared times 8 to the 1/3. If I rewrite those, this would be 4 squared is 2 to the fourth, right? 2 squared squared. 8 cubed would be 2 to the third to the 1/3, which would be 2 to the first. I can now combine those. The other thing that we can do, as I talked about a minute ago, is use this as a solving strategy. So we're just going to get a little glimpse of that today. That's not going to be our big focus, but I want you to be aware of where we're going to take this stuff. So if we take a look at our last few examples here, if the bases are already the same, that's going to be really helpful as I talk about being able to find what that value of x is in the exponent. So if we had, let's say, 15 to the third power was equal to 15 to the something power, what's the only thing I can put in that box and have this equation be true? Have one side be equal to the other. 15 to the third power is equal 15 to the third power. They have to match, right? The exponents have to be equal. This same idea applies if I've got 15 to the third power equals 15 to the x plus 5 power. That means that whatever I have here has to be the same as whatever I have here. So if we hop down over here, 3 to the fourth power equals 3 to the x minus 1 power. Since the bases are the same, that means the exponents also have to be the same, right? 15 cubed is only equal to 15 cubed. So it doesn't matter how I've written that exponent. I know that the exponents have to be equal to each other. So if I want to solve for x, I don't need the bases since they're the same. I can just focus on the exponent. And from here, we can solve for x. Now, this gets a little stickier when our bases are not the same. But we can rewrite 4 so that it has the same basis too. Because what did we say a minute ago? 4 is 2 to the what power? 4 is 2 to the what power? 2 to the second. Thank you. So this, I could actually write as 2 to the second power. And now that the bases are the same, I can basically ignore the bases and focus in on those exponents. If the bases are the same, the exponents have to be equal. Distribute here. At this point, I'm giving you something right now that I could have given you in like 8th grade, right? You know how to solve linear equations like this. This is not a big deal. I'm going to distribute. I'm going to move my x's to the same side. I'm going to work to get x by itself. Oh, sorry, this is -9. There we go. That looks better. And then I get x to be equal to -3. I would like you to try the 2 remaining problems on this page. The top one, the bases are already the same, so that one shouldn't be too bad. And then the bottom one, you're gonna have to do some rewriting on that one to get the bases to be the same. And then use our same strategy here. Remember, if the bases are already the same, you just have to worry about the next. Okay, let's take a look at these. So for this first example here, your base is 7 on each side. That means we only have to worry about the exponent. So this would be 2x equals 5x minus 6. I'm going to move my x's together. So I get 0 equals 3x minus 6. And then I'm going to get the x term by itself. And then get x by itself. And we get 2 for x. Our second problem was a little trickier because you have to rewrite to get the same base. What should I rewrite these as? I actually have to rewrite both of them on this one. What base should you use? 3. So 9 is 3 to what power? 3 to the second, 3 squared. So this is 3 squared, so the 2x plus 1 equals 27 is 3 to what power? 3 to the third. So the x minus 4. Once the bases are the same, I can focus on the exponents. So this would be 2 times 2x plus 1 equals 3 times x minus 4. And then again, just be careful with your steps as you're solving. I'm going to distribute. So I get 4x plus 2 equals 3x minus 12. And move my x's together. And then get x by itself. Again, this is where we'll get to eventually using our exponent rules, being able to rewrite something, and then using our exponent rules to be able to do combining if I need to, like we saw here, or like we saw here. Questions for me for today? All righty. For the rest of our class time, I want you to work on a practice assignment you have on delta math.